get into in this module is information systems and some of the IT components. Now, I realize that a lot of you who are probably going through this ISM course are not IT or cyber dyed-in-the-wool, techie types. So what I've noticed that this is probably one of the harder part of your class is understanding the IT infrastructure. So we're going to go through this, and this is really at a fundamental level to help you kind of get an understanding of some of the core principles of IT. All right, let's get into this. So what we're going to look at, hardware, we're going to look at software, we're going to talk about virtualization, cloud computing, storage, and networking, layer 1, layer 2, layer 3 networking. So when we think about hardware, one of the things I think is very important to understand is basic computer design. What am I talking about? Well, computers are built in a stack. They're built, in a hierarchical fashion. You start here at the bottom with computer hardware. That is your CPU, your central processing unit, hard drive, your storage, monitor, all of those components that's a part of that of the computing system. And now, on top of that hardware, that's where we install an operating system. An operating system could be a Windows operating system. You may be a Mac user or a Linux user. But either, regardless of what type of operating system you prefer, it sits on top of and is installed on top of the computer hardware. Then on top of that operating system, this is where we install our computer applications. Now, these could be office products, video games, whatever type of applications that you use. So you see we have a stack, everything, and it's done this way by design. Why? So that you as the user, that interface, what you interface with day to day mostly are computer applications, and those applications interface with the operating system. There are very few things as a user you can do to get to the hardware, because for security reasons, because those things are blocked. Now, one thing is, like, for instance, Control-Alt-Delete when you do that on a Windows system. That's a command that goes right into the shell and is able to talk, through the operating system and into the BIOS, your basic input-output system that controls your hardware. But most of the commands that we use day to day, they talk to the operating system, then the operating system talks to the application. Operating system also controls the hard drive and things of that nature. So that's a security feature built in the design and the stack of a basic computer. At the heart of any computer is the central processing unit, the CPU. This is where all the magic happens. Now, when we talk about this CPU, now I will tell you this, guys, even though I know we're in 2023 and we are just immersed in technology, but still, computers operate very simply at the core. They really still do one thing at one time. They're big adding machines. That's really all they are. So when we look at CPU does four things, like I said, and that is where all of the magic happens, like I say, within your computer, is on the central processing unit. Now, it does four things. It fetches, decode, execute, store. Fetch means that it goes to the hard drive and it gets your program instructions. Now, when we think about program instructions, think about your computer in two ways. Let's say that you want to write a Word document. You got to do a term paper, right? Well, two things go on. You have Windows on the operating system, but let's say you're using Microsoft Word. Well, Word itself is the instructions that tells the computer how to actually format and do your paper. Now, as you're writing the paper and you save that document, that's saved also, not to be confused with the execution software of Microsoft Word. So the first thing that happens is your operating system, your CPU has to be told, okay, that something needs to be, some action needs to happen. So that's why now your operating system does a fetch. Okay, go to the hard drive and bring up the program execution instruction and put that into the computer's memory. Got it. That's what it does. Next step, it decodes. Now it's going to take that information, those lines of code that it just fetched, and now it's going to go into this decode mode where it says, okay, what do you want me to do with this? I've got it in memory. Now what's the next thing you want me to do? And then that goes into the execute mode where it says, okay, I want the lines of code says, save this document or insert this picture here, do whatever you're doing in your Word document, and then store. That's when you say, okay, I've finished my document and I want to save it, and then it takes that code out of memory and pushes it where it needs to go to save it on your hard drive. It's also, let's say then you close Word, and then it takes all the Word, Microsoft Word instructions out of the registers or out of memory as well. So that's really at the heart of your computer, that central processing unit. You know, it's almost like cooking. I mean, when I say that, you're in the kitchen. Okay, I want to make something. The first thing I want to do is I got to fetch. I've got to go to the refrigerator. I've got to go, well, I need a cookbook. Okay, first thing I'm going to do, I cook by recipes, so I'm going to go fetch the instructions, the cookbook. I pull that off the shelf. Got it. Now the cookbook tells me I'm going to need these ingredients, so I'm still doing a fetch. You know, so now, because now it's starting to decode. Okay, I need to decode. Got it. Go to the refrigerator and get some butter and eggs. Go to the shelf and get some noodles. Go here and get those things. And now we go into the execute mode. Now I've got all my ingredients on my desktop, on my countertop, I'm sorry. And so now I'm ready to put together and make macaroni and cheese or whatever I'm going to make. So I execute. I finished cooking that macaroni and cheese. I'm not ready to eat just yet because it's 1 o'clock and we're not going to eat until 4 o'clock. So what do I need to do with it? I'm going to store it. I'm going to take that freshly cooked mac and cheese and put it back into the refrigerator. So you see that cycle, we use it in life all the time of fetch, decode, execute, store. Makes sense, right? So where does this happen? Like I say, your fetch and store, those are done in memory. Your decode is actually, and execute are done within the CPU itself. And really a lot of that is in your arithmetic logic unit, your ALU. That's what actually performs the magic. Really think of the ALU kind of like me cooking. Here again, I got my cutting board, and I'm sitting here, I'm dicing eggs, and I'm chopping up everything, cheese, and everything I need to put into that mac and cheese. So I'm executing right there. Now, like I said, with the computer, all it can really do is add. And he's like, really? Yes, that's all it's doing. It's adding, it's doing binary addition of these computer words, and we're going to talk computer words in a couple of slides, that it brings in and it knows, and to know what to do with it. It's comparing to see which one is the larger, which one is the smallest, and it just do addition. And you say, well, just addition? Well, if you think about this, guys, they never told you this in grade school, and you should go back and sue your teachers. No, but really the only mathematical operation that we ever do is addition. Think about it. What is subtraction? It is negative addition. You're adding a negative number to another number. Multiplication, that's repetitive addition. You're, if you're going to do 3 times 3, you're adding 3 plus 3 plus 3. Division, the same thing. You're just doing, it's really like negative multiplication. You're multiplying by in a negative manner. So really all the computer and us, we all ever do is really addition. We just add. So that's the CPU, I mean, trust me, there's a lot more that goes on in a CPU than what I just covered. But for the purpose of this course, that's really about all you need to know of understanding the CPU. Now, a couple things that you also will see with respect to CPUs is the performance. Now, these are some things that you've probably heard and maybe not understood exactly what they meant when we talk about CPU performance. Your data bus width. Now, and that has to do with how many lanes of traffic that takes information. You have a bus inside of your computer, not like a yellow school bus, or not a special bus, but it's basically like a highway of wires that run to your CPU and throughout your computer. And it's just saying, how many lanes does that bus have? The more lanes it have, the larger computer word that it can handle. It could be it can transfer data. It could be a 64 bus computer, 32 bus, 16 bus. An 8 bus computer can only take one computer word at one time. Computer words are typically 8-bit. These are 8 bits. So if I have a computer with 16 bus, now it can actually take 2 words at one time. A 64 bus computer can take 8 words at one time. So you see, the wider the bus, just like the interstate highway, the more lanes you got, the more traffic that it can carry. Now, word size. Now, like I say, that's the maximum number of bits of data that the CPU can process at one time. Most of our machines now, we're up to 64 bits, meaning that it can process 8 computer words at the same time. So if I have a computer with 64 bus width, and it also has able to process 64 bits, that computer can run pretty fast. But let's say that, and this is something to think about when you're buying computers and you want to get a little techie with it. It's a 64-bit machine, and I can run 64-bit software. But if you have an older computer and it only has a 16-bit bus on it, you're really not gaining that much, because you can only take, even though you're able to process 64 eight words at a time, you can only bring in 2 at a time anyway. So you kind of see what's going on there. Now this is when you hear sometimes too your clock speed, or how fast is a computer running, and this is typically now measured in gigahertz, a 3.2 gigahertz machine. Basically, that's how fast that traffic can move on the bus at that speed, and how fast that clock is running on the within the CPU. Just the faster the speed, the more it's going to process. Again, though, you got to remember, you could have a computer that's running at 4 gigahertz per second. However, if the bus speed or the word size are small, still it would be like on a highway. If I have like going to the airport, most airports, you got to get a ticket. You got to go through this with all the lanes that go up to where you get your ticket. Now, I can have 60 lanes where they open up, to get tickets. However, if the highway going there only has, 2 lanes, I'm still congested. Or transversely, let's say I've got a highway that's got 8 lanes, but then when I get to the toll booth, they only got 2 of them open. So you see the processing of when you say how fast can your computer run, how fast can it process? It is a mixture of all 3 of these. So to give you an idea of some things you may see when you're looking at computer specs. Clock speed, 1 gigahertz. The bus, front side bus, 133 megahertz. That's how fast the bus is taking things in and out of the computer. So even though the clock speed may be really high, 1 gig, that computer can operate at 1 gig, but the bus speed is still low. So you may not be getting stuff in and out. How much cache? Now, cache is just a type of memory, but that's where your instructions are held. So when it has to go to the hard drive, think of these 2 as countertop in your kitchen. If I have a lot of countertop, I can go to the refrigerator and bring a whole bunch of stuff out at one time, and I don't have to go back to the refrigerator. I can start cooking. If I have a small countertop, I can only bring so many things out, set it on the cabinet. Now I got to go back to on the counter. I got to go back to the refrigerator, grab more stuff. So you see how much time I'm wasting going back and forth to the refrigerator or back and forth to the pantry because I don't have enough room on my countertop. So these cache, this is just a different type of memory, and that memory actually sits right there on the CPU itself. So these things all deal with the CPU performance. Now, something that we sometimes also, I know you could probably get confused, is memory. I'm going to talk about 2 things, memory and storage. It's a fundamental difference between the 2. Many times I hear people, they talk about this and they get them confused. They say, well, how much memory does your computer have? Well, it's got a 2 terabyte hard drive. That hard drive is not memory. We're talking about volatile memory, like RAM, random access memory. Okay, that's really your countertop. And here again, go back to that cooking analogy. Think about your RAM as how much countertop space you have. Think about your hard drive as your refrigerator, long-term storage. Big difference between your refrigerator and your countertop. So when you say, now, if we talk about how much RAM, I've got 64 gigabits of RAM, or I got 128 gig of RAM. That's how much countertop space you have. Just like on your phone or on your computer, you say, oh man, this thing got 256 gig of RAM. That means that it can go to the hard drive, pull a whole bunch of stuff off and bring it into memory and process it. The more things and why is that good? Because RAM is faster than your storage in your hard drive. Your computer needs that. You got a computer that's running at 2, 3 gig. So you need RAM to hold those instructions and feed it in at the right time and at the right time. Different types of RAM, so this is just so if you have to see some of these terms, gives you an idea of what they mean. So when you hear about SDRAM, that's synchronous dynamic random access memory. It means that it is synchronized with the clock. So if the clock is running at 1 gig, every time the clock pulse does this, it is synchronizing the RAM. Also, you got in this the RD RAM. You don't see that much, but that's it's using the bus to send and receive data within 1 clock cycle. It's a little bit faster than SDRAM. Then you have double data rate SRAM, DDR. That's what you see a lot now when you buy RAM. It's a DDR, double data rate. because now it's a type of SRAM that's able to send and receive data at the same time. So now I can send and receive on one clock pulse. With just SRAM, it sends on a pulse, receives on the next pulse, sends on a pulse, receives on the next clock cycle. So you see, even if your computer was running at 1 gigahertz, now if you just have SRAM, your memory is only being refreshed at 500 megahertz. However, double data rate, it is being refreshed at the same speed at 1 gig. Just little differences between the different types of RAM. Now we talked about, like say, your volatile memory, now non-volatile, meaning that it doesn't go away. Volatile means when I turn my computer off, it goes away. When power is removed, it goes away. So everything, that's why if you don't save, how many times have we done that? You're making a change and the power goes off on your computer and you go, I just lost everything. Why? Because I didn't save. Because everything that you had was sitting in this space right here, volatile memory. It was in RAM. You did not save. If you hit the Control S or hit the little disk-looking icon, you would have pushed that back to the refrigerator. Everything you had, you left sitting out on the counter, and it spoiled. And you go, I forgot to put the milk in the refrigerator. And you come home, and the milk is spoiled. Why? Because you didn't save it. So that's, here again, I know it's a kind of a crazy analogy, but think cooking and a kitchen whenever you think computing. Now storage, you got hard drives, you got solid state drives, you got magnetic disk drives. There's a lot of different type drives out there. Where a lot of our machines are going to now is SSDs, a solid state drive, SSDs, solid state drives. And now you may hear them call it these M2. If you're looking at computers, there's an M2 slot. Well, this right here, this is a picture of what an M2 drive looks like. And you see it's just a little, like a little circuit card, and they're small. They're small, that plugs into, many times right on the motherboard. They're actually screwed in and plugged in right on the motherboard. So you don't have this big, large hard drive anymore like it used to be, where you had these big drives. And you get much more capacity. It's the same amount of capacity that you probably had here on this drive, was maybe 1 terabyte. Now you're getting 1, 2, 3 terabytes on these little small cards, these solid state drives. Okay. Now, the thing to remember, especially from an ISM perspective, the most important part of a computer is not the hardware, it's the data. It's the data. That's what we're protecting. So that's why understanding some of these things are important, and knowing how to back up your data, know how to protect your data, because that's where it's stored at. Okay, let's talk about software real quick. When we think about operating systems, I want to talk about operating systems, not so much third-party software. Really talk about the operating systems that operate on top of the hardware. Now, this is where you could be a Mac user, you might be a Windows guy, and some of us, I hear we love Linux. So those are probably the 3 largest categories of operating systems. And Windows by far probably, being the largest market share of OS, is Mac followed behind that, and then like I say, you got a group of Linux guys. Now, Linux is very clandestine. It is slipped in and out of a lot of places, okay? So when we look at an operating system, regardless of if it's a Linux, if it's a Windows, if it's a Mac, it does some basic functions, okay? All that operating system is programs, computer programs, code used to manage and control the CPU. It manages the memory we just talked about. It manages your file systems. So like I said, if you're on a Windows machine and you open up File Explorer, that operating system is which manages that. It also manages what we call your I/O, your input-output devices. That's how when you plug in a mouse, a keyboard, USB, whatever it may be, your operating system recognizes that and controls that, as well as networking. So if you got Wi-Fi, or you have RJ45 cable, Ethernet cable plugged into your computer, that operating system is managing these things. Now, not only does it manage it, but it manages it in a very logical fashion. At the center of any operating system is what we call the kernel, okay? Not like in the military, but this is more like a kernel of corn. It's the core. I said, and that's what does all the management of your software. It translates requests and instructions for the CPU. So the kernel is sitting there at the very center. Now, outside of that kernel, that's where we have what we call APIs. Application program interfaces and drivers, device drivers. Then on the outside of that core, we have our operating systems applications. So what I mean by this, please don't get these confused with user application. Some examples of operating system applications. If you're in a Windows environment, PowerShell or a file manager, the control panel, all where you configure your settings, for your printer and mouse, keyboard, all those are operating system applications. And so I say, so when and these are the ones, if you just get Windows out of the box and install it, that's what's on there. Those are applications supporting the operating system. Then also, I'd say, which you're going to be, especially in a business environment, the guys who do a lot of work on computers, they love operating not from GUI many times, graphical user interface, but from command line. And this is where it gives them so much more power, so much more flexibility on what they do with the computer. But all of that is in there. So many times you hear that called, shell. That's why the word PowerShell. So that PowerShell is used. You can go in within Windows and you can write scripts and do those type things from the command line interface. Now, then on the outside, and these are your user applications. However, remember, your user applications are not a part of the operating system. These are external, these are third party, here we call that third party applications that reside here. They sit on top of that, but they are not a part of the operating system. So that's what the operating system looks like. So now when we look at these different types of operating systems, there are advantages and disadvantages. And trust me, we could go back and forth for days, of advantages, disadvantages. So in a Windows environment, some of the advantages, one is it's readily available. It's easy to use, very familiar. It is like the gold standard now of operating systems at home and businesses and everywhere. It supports gaming if you're a gamer really well. Windows, they have a Microsoft help desk available. You get updates pushed to it constantly. So those are some of the advantages, and that's why it has such a large market share. Some of the disadvantages, the price. Windows, if you're buying it, can be expensive, or if you're having to subscribe to the 365, that can be expensive. There are some issues with security, as with all operating systems. It's not like Windows are any worse so far, but there are things with security and stability. And why is that? Well, Windows was built to run on pretty much any type of hardware. Well, because of that, they have to write a lot of interfaces to be able to talk to these different hardware platforms. So it's not unique to a single piece of hardware, and it's not written that way. So it can become unstable from that perspective. But yeah, but Windows by far is like I say, has the lion's share of the market. When we look at the Apple or the Mac environment, like I say, there are people who swear by Windows, they swear by Mac, but it depends on what you're doing. I use both, in a work environment, I use Windows almost all the time. I come home and I enjoy a Mac, especially for doing things like this, for videos, for doing graphics, for doing media. The Mac environment works good for me, but you can do the same thing in a Windows environment or a Linux environment. Now, some of the advantages, like I said, is the graphics. People say they like it better from that perspective. More stable. Why? Because it's a software that the operating system was built to run on a certain hardware. When you buy the Mac, it's not like I can buy the Mac OS and just drop it on any hardware. So the hardware and the software are tuned together to run together, and that provides stability and a little better security, a little more straight line. Some of the disadvantages, like I say, a lot of people write software for Windows. And you can find a lot of software. Not so much with the Mac, it's its own environment, so you may have a hard time finding some software that will run in a Mac environment, some applications. Some people don't like the mouse, actually some of the user interfaces, because the user interfaces are a bit different. Again, expensive. And this is from a total cost of ownership. Like I said, I've owned Windows machines and Macs, but I will say over the long run, my Mac environment have been probably least expensive because I'm still using a Mac laptop from 2013, and that is still updatable and still running in a good environment. Now, I know this is a big one for a lot of people, is the gaming. Mac is not really built well suited for gaming, but I know a lot of people go to, they don't game on desktops, they have their gaming stations. The Linux environment. Now, I would say Linux, one of the big things with Linux is, for the most part, it is free. It's open source. It's built by a consortium of developers. So it's not just one individual or one corporation like Microsoft or Apple that owns Linux. It is an open source environment. So no matter what I say over here and advantages, I'll always come back to free. So you pick a disadvantage, well, guess what? It's free. All right, but is it stable? Yes, because you have now thousands of people around the world who are updating and inputting patches and keeping the operating system running. Secure? Yes, it just depends on how you want to measure it secure. But it's if you are a Linux person, you can secure that down to where you can lock it down really tightly. I'd say it's low PC requirement. You can get a Linux kernel that can run on almost nothing. I don't know if you're familiar with what we call Raspberry Pis. Little small computers in a box about that big, and yeah, you can run Linux on that where you could never be able to load Mac OS or Windows OS. So there are advantages, to this environment, but you have to understand that Linux environment to be comfortable with it. Some of the disadvantages very similar to the others. Like I say, not all software runs in the Linux environment, but a lot of times you can find a Linux comparable one that someone has developed. Support, like I say, it's based on the consortium of people. Like I say, you really have a lot of, not so much a help desk, but you've got wikis, you've got websites where people will give you the answers you need from the community. It's really a community-based software. It's a little more challenging to learn, use, and install. You really have to be versed in that Linux environment to be good at Linux. All right, so when we bring all these pieces together, we talked about hardware, right? From the hard drive, our memory, cache, all the way over to our CPU. Well, what sits on that hardware? Yes, your operating system and your applications. With your kernel, your API apps and drivers, and your operating system applications. So how does this all come together? And as well is your input-output devices. This is your printers, keyboard, monitors, whatever it may be that you interface with, and from a human perspective, to be able to input and take things out. So if I want to do something, right, the first thing, like I say, this operating system kernel, once I say, okay, I want to go and update a Word document, well, I use my input-output device, keyboard, right, type that in, and the kernel goes to the hard drive, pulls that document from the hard drive as well as the Microsoft Word instructions, and it loads that into memory, into our RAM. That's why you see now having a lot of RAM is good. The more RAM, my rule of thumb on buying RAM, get as much as your wallet can stand right up front. Chalk that thing. If that computer is able to hold, 256 gig of RAM, buy get it, because you can never have too much RAM. It's like, I don't think I've ever walked into a kitchen and talked to anyone who cooked and says, there's just too much counter space in this kitchen. That's something I don't think you will ever hear. Never have enough counter space. All right, so now that code is pushed into cache. It'll be level 1, level 2 cache. Goes to the CPU. Actually, that's where we're doing that fetch and store. So it's fetching from memory, taking it into the CPU, and that's where that CPU is doing the decode, execute, and it may push it back out the store and the process is executed. The kernel says, okay, write that back to hard drive. So you see everything works together. The hardware, the operating system, software, as well as your user applications, and they all tie together, and you interface with it with your I/O, your input-output devices. Okay, let's take a quick look, really quick, at some other type of operating system. One is called mobile operating systems. These are the things that are in your phones, for the most part, right? Phones and tablets. You see, there's been several types. Yeah, many of us are probably not familiar with some of these. Some of these are not around anymore. But RIM, Windows Mobile, Linux, Palm, the Android systems. Now, I will say a lot of your phones actually have two operating systems. They have one operating system is what interfaces with the user on a day-to-day basis. That's when we want to dial. And then it has a second operating system that interface with the cellular network, the cellular towers and all those. But like I said, over the years, like I say, no matter what type phone you've got, typically today you're going to see either an Android or iPhone, the iOS environment. Now, there are other ones are still out there. Like you look at your Google, your Pixel and all those. They are likewise running some very lightweight Linux OS underneath that. embedded operating system. Now, these are operating systems that you don't see. For instance, like in your car. Your most new cars now, you got the entertainment center in the middle, and it runs everything. Well, yes, there's an operating system that has to be able to control the code. So when you press a button, it goes somewhere. Cameras, anything with electronics now that you're able to interface with, most of the time there is some type of embedded operating system. And I would say probably 95% of those are running some type of Linux distribution, something that's very, what we call lightweight. You know, the great thing about Linux, okay, let me go back a couple slides. I kind of missed something right here. If you want Windows, if you say I'm going to get Windows 11, well, what are you going to get? You're going to get all of this right here. All three of these layers packaged together. And if you want to, you get Mac OS, right? What you're going to get? All three of these layers packed together. However, you can go to Linux and you can just get a kernel. Okay? And you can get that kernel for free. And then with that kernel, you can build your own drivers and application interfaces as well as operating system applications. So think about that for a second. That's when we say lightweight, that's what we're talking about, is that now all I want this operating system to do is about 5 things. And that's it. I don't need to install all of these layers. That's why that's why people really love Linux in this environment. Because a lot of these devices don't have a lot of memory. It's not like I got a 1 terabyte hard drive in my camera or in your coffee pot or in your TV. So you don't have a lot of memory in there, so not a lot of space to keep things. So that's why having a very lightweight operating system, and it only is going to do a few things. Just it's not like a regular computer. So when you talk about these embedded operating systems, they are in a lot of things throughout the environment. Okay, I hope that helped you out a little bit with the understanding the computers from a hardware, from a software perspective, and from applications, and seeing how these pieces fit together. We're going to come back with virtualization.